Sustainable development has been defined as development that meets present needs without damaging the basis for meeting future needs. This implies increasing and improving manufactured capital without destroying natural capital. An inherent tension exists between the ideas of sustainability and economic growth, as we cannot have unlimited economic growth with finite resources. Sustainable development must demonstrate a long-term balance between economic growth, society, and the ecosystem's health. Focus areas to be considered when considering sustainable practices would include land use, site ecology, community design and connections, water use, energy performance, energy security, materials and construction, light and air, climate design, and design flexibility. The concept of sustainability, although important to managing national capital, is difficult to define. Along these lines, the GDP, gross domestic product, and GNP, gross national product, fail to capture important environmental and social factors. Is there a single alternative measure? The differing approaches are not mutually exclusive, but do offer a broader picture of the economy and ecosystem interactions. A combination of techniques, while reviewing standard economic analysis, will offer varied insights into the issues of population, agriculture, natural resources, energy, and pollution. Global population growth remains a high and legitimate concern. An ecological perspective recognizes more stringent limits to the population carrying capacity of both regional and global ecosystems. Given the extent of existing environmental damage, especially where this damage is cumulative or irreversible, the challenge of providing for significantly larger populations pose severe challenges to the Earth's ecosystems. Income. Many countries may have created development funds for the purpose of financing resource offsetting investments. A problem with such funds are that they are normally done in the public sector, which could lead to appropriation by powerful politicians, investment in unrealistic or inefficient projects, or used for paying for bills that have a short-run value. Reduction of fossil fuels will not only slow global warming but also improve human health. These types of health problems to consider would be ones that may be caused by various levels of environmental stressors. An environmental stressor is any physical, chemical, or biological factor that has caused an adverse effect on ecosystems or human health. Industrial ecology adopts an overview of the entire process of resource use and waste integration in all sectors of the economy. Strategies for making the economic process more compatible with natural systems may be promoted through the market process, government policies, or economic incentives. Industrial ecology provides a powerful prism through which to examine the impact of industry and technology and associated changes in society and the economy on the biophysical environment. It examines local, regional, and global use and flows of materials and energy in products, processes, industrial sectors, and economies, and focuses on the potential role of industry in reducing environmental burdens throughout the product life cycle. Industrial ecology asks us to understand how the industrial system works, how it is regulated, and its interaction with the biosphere, then on the basis of what we know about ecosystems, to determine how it would be restructured to make it compatible with the way natural ecosystems function. The field encompasses a variety of related areas of research and practice, including material and energy flow studies, which is known as industrial metabolism, dematerialization and decarbonization, technological change and the environment, the combined areas of life cycle planning, design and assessment, design for the environment, eco-design, extended producer responsibility, which is product stewardship, eco-industrial parks, which is industrial symbiosis, product-oriented development policy, and eco-efficiency. Accelerated climate change. Two types of measures can be used to address climate change. Preventive measures tend to lower or mitigate the greenhouse effect by 1. Reducing emissions of greenhouse gases, either by reducing the level of emissions-related economic activities or by shifting to more energy-efficient technologies that allow the same level of economic activity at a lower level of CO2 emissions. 2. Enhancing carbon sinks. Or 3. Preserving forests that recycle CO2 into oxygen, which will have a significant effect on net CO2 emissions. Adaptive measures deal with the consequences of the greenhouse effect and try to minimize their impact. Adaptive measures examples include either construction of dikes and seawalls to protect against rising sea levels and extreme weather events such as floods and hurricanes, or shifting cultivation patterns in agriculture to adapt to changed weather conditions in different areas. A word I add is accelerated in front of global warming for the naysayers that argue that global warming is natural and has happened in the past. For the rate is the problem we are trying to fix, and how do we slow the rate down? In the context of sustainability, carrying capacity is the size of the population that can be supported indefinitely upon the available resources and services of supporting natural, social, human, and built capital. The concept of carrying capacity is closely related to the idea of capital. The term capital is most commonly used to refer to money and material goods. However, in the context of sustainability, communities have different types of capital that need to be considered: natural, human, social, and built capital. Together, these types of capital are referred to as community capital. All 4 types are necessary for communities to function. All 4 types need to be managed by a community and need to be cared for, nurtured, and improved over time. A community that is living off the interest of its community capital is living within carrying capacity. A community that is degrading or destroying the ecosystem on which it depends is using up its community capital and is not living sustainable. Carrying capacity is much harder to measure for human, social, and built capital than for natural capital, but the basic concept is the same. Are the different types of capital being used up faster than they are being replenished? Examples include a community that allows its children to be poorly educated, undernourished, and poorly housed is eroding its human capital. A community that allows the quantity of its social interactions to decline through lack of trust, respect, and tolerance is eroding its social capital. Or a community that allows its buildings, roads, parks, power facilities, water facilities, and waste processing capability to decay is eroding its built capital. Additionally, a community that is creating built capital without considering the future maintenance of that capital is settling upon itself for eventual decay. How do countries maintain growth in the face of diminishing natural resource stocks? Ecological economics gives special emphasis to the concept of natural capital. While much of standard economics concerns the accumulation and productivity of human-made capital, ecological economics focuses on maintaining the natural capital systems that support life and economic activity. In this perspective, economic systems cannot grow without limit, but must achieve a sustainable scale for economic activity at which the planet's ecosystems are not subject to undue stress. World trade expansion has raised the issue of the relationship between trade and the environment. As we look at global impact, trade expansion can have environmental implications at either the national, regional, or global level. International trade agreements make provisions for resource conservation and environmental protection. In the real world, hundreds of countries trade trillions of dollars worth of products. Where significant environmental external issues occur, trade will reallocate these issues among countries. Another reality is that the length of time to ratify an agreement can be an extensive effort, as the agreement will become a legally binding document. Expanded trade tends to increase the scale of production for the individual countries and world as a whole, meaning that the total volume of pollution and environmental damage is likely to increase. Trade also involves energy used for transportation, with resulting air pollution and other environmental consequences. Indirect environmental effects of trade might also occur, for example, when larger-scale export agriculture displaces peasant farmers onto marginal lands such as hillsides and forest margins, which leads to deforestation and soil erosion. Health and safety issues arise in trade are not always easily resolved at either domestic or international levels. Trade expansion may also have direct or indirect beneficial effects on the environment. According to the comparative advantage theory, trade causes countries to become more efficient in their use of resources, thereby conserving resources and avoiding waste. Trade liberalization also removes distortion subsidies and pricing policies, improving the efficiency of resource allocation.